Welcome to Helpful Hints for Chapter 4's lab project. We'll be working with systems of linear equations for this project. For lab number 4, you're given two equations. Here's one equation, here's the other. And your job is to plot them on one set of axes, and then you'll see an intersection point. So what we're going to do is we're going to graph the lines individually first, and then see where they cross. So we have a couple of options. So option 1 is to find the intercepts for both of them. So for this one right here, then I have the XY chart. If x is 0, then I'm going to cover up the x, and then I'm going to find that negative y is equal to 3, or y is equal to negative 3. And the other one, if y is 0, I'm going to cover up the y, and then x is equal to 3. For the other, we have an xy chart. Going to find the y-intercept first. So if x is 0, then y is 3. And if y is 0, then I have 1/2 x plus 0 is equal to 3. 1/2 x is equal to 3. Multiply both sides by 2, x is equal to 6. And your job is to identify the coordinate where they intersect. The other option is to convert both of them to y equals mx plus b form, the slope-intercept form. Then we get these coordinates right here. We get these lines. We're still looking to identify this coordinate right here. So 7x minus 6y is equal to 12. And you have a couple of different options. So it says substitution. Now when you want to use substitution is when you can isolate one variable. So what you could do is find the easiest one to isolate, and that's going to be this negative x that's right here. Except that I can't use negative x. The problem is I need an x, not a negative x. So what I'm going to do is I would multiply everything in the second equation by a -1. I would multiply here, here, and here, and then the result would be x equals, and then I have something I can work with. I would take the result from that, and I would substitute for this x value right here. Then I would have one equation that's all written in terms of y. I could solve for y and go back and pick up that x next. So, now the other option is using elimination. So I have another problem with that one, and that it's not aligned correctly. I need things to have nice little vertical x's have to be in the right row and so this one I'm good with, but this one not so much. So also this one right here, it's not aligned correctly, so that's not going to work. What I'm going to need to do instead is I'm going to need to rewrite these equations so that I get things in the right spots. For example, I'm going to take this x right here, and I'm going to have to add x to both sides. I'm going to have to subtract 9 from both sides so that I can get the right kinds of terms to align. And the next thing I'm going to have to do is multiply by a constant of my choosing so that I get additive inverse coefficients. In other words, I need to have, let's say, negative 17y and positive 17y in the two different equations so that when I add them down, then I get something that's equal to 0. I want to eliminate one of my variables. So then after you get them in the right order, then we're going to take some sort of a vertical approach and then add them down. So that one's we're going to add all of these down once we get there. So those are your two methods. And the next thing is, did you find the same solution for parts A and B? When you graphed it, did you get the same solution as when you use an algebraic method like substitution or elimination? So you should, and the reason why is because graphically speaking, you should identify where they intersect as the same thing as the solution to an algebraic method like substitution or elimination. You could be off, maybe because of human error, because you didn't know how to graph them, something like that. So you should get the same answer, but if you don't, then explain why you did not get the same answer. The next thing without giving away too many of the juicy details, is you have two new equations, and we're going to look for where those two ships are going to cross paths. The problem with this one is that you're looking for their one intersection, and you're not going to find one clean solution like you did in the last one. You're going to find something that's different. If you were to solve this equation and this equation for y equals mx plus b, and put it in that format, you would see something about the slopes. You're going to identify that their slopes are the same, but not everything about this is the same. You have two jobs right here. First of all, you're going to use graphing, and that's the primary method. You're going to graph these first, again, choosing the method you'd like. And then secondly, you're going to use either substitution or elimination. Now, when you graph, you should see why you're not going to find a solution. And when you use substitution or elimination, you should get something that algebraically means that it doesn't make sense and you will not find a place where they intersect. Those two ideas should match, but you should graph it first and then also use an algebraic method. The next thing is another set of equations. You have two equations right here that we're going to use, but in those equations, then still you have something that is a little unsettling, and you're not going to find a single solution. It's not going to be the same as number 2. It's also not going to be the same as number 1. You have yet a third scenario here. And just because you're getting something that looks a little weird doesn't mean that it's wrong. So we need to explore and make sure that we identify why it's weird. There could be some algebraic reasons why it's weird. We're going to solve the system, first of all, by graphing and then using any other method. What do you observe about those ships? So when you see those two, you should identify that they don't have a single solution, but they have a different kind of set. And then you're going to get something from your algebra that's, you're going to find something similar to it didn't work the right way in number 2, but it's going to not work differently here. And you identify why that is and what kind of solutions you get. And then, therefore, once you're done, you should be able to identify when you get one kind of odd solution in number 2 and why that matches that kind of graph versus why you get some other abnormal solution for number 3 and why it matches that kind of graph. And that's where you're going to graph. The last thing we do is revisit a few ideas from Chapter 7. Remember, we talked about before that the distance formula is really just a use of the Pythagorean theorem, where we have to take our difference in x's and we take our difference in y's. We apply them and we find that distance. A couple of things I'd like to point out, though, is that this is grid units that we're talking about, because we're starting with algebra. We're talking about math as opposed to using a map. So in the map, then it's always scaled down, and this scale tells us that we're going to identify that one grid unit is equal to 30 miles. So you will need to identify how long this really is. You'll round that answer to the nearest mile. The next thing is you're going to find where they meet. Again, some idea from Chapter 7. In Chapter 7, we talked about the midpoint formula, where you average the two x's and you average the two y's. And that should give you a single x and a single y value where they meet in the middle. Now the last thing is that if both ships are traveling at 40 miles an hour, how long will it take? Now we have that d equals rt from right here. You remember this one from a long time ago. So with your d equals rt, then we have the rate. The time is the thing that we don't know about yet, so this is what we need to find. But this distance right here is a problem, because we need to use the distance that's from up here in letter B. However, I can't use that whole distance. Here's why. If one ship is over here and he's traveling to where this ship is, but this ship travels the entire distance and goes over there, they're still not ready to meet and fight. They need to go to that midpoint. That's why they made you find the midpoint. So what one is doing, here we go. So one is going here, to here in the middle, and the other one's going here in the middle, and they're going to meet in the middle. So you're not going to use the entire distance from part B, but you're going to use half of the distance. So you can get a solution from up here, and then you're going to multiply it by half, and then that's going to be the thing that you need down here. as the distance they're going to travel. And then you'll be able to solve for t.